Hello, pre-calculus students and seekers of general truths. Let us continue our study of polar functions here, and in particular Rose curves, with another polar function. And let's start out with, again, some of the simpler stuff. The domain of this function is going to be all real numbers from negative infinity to positive infinity. And the range of this function is going to be negative 1 to 1 as well. So this is the cosine graph, right? So there's nothing particularly special here, negative 1 to 1. Okay, and this also tells me that the max r value, or the biggest distance from the origin, is going to be 1, and the minimum r value, and again we're talking absolute distance, is going to be 0. So the number in this range that's closest to the origin is 0. Now, rather than using a grapher, let's just try to figure out how many petals this thing is going to have and what is it going to look like. So let's do the same trick that we did before. Let's set the max r value to 1 and solve for theta. Okay, so 1 is equal to cosine of 3 theta. Now I know that cosine of 0 is going to equal to 1, so that lets me take the cosine out of here. So again, if we look at the unit circle now, right, at theta equals 0, you have the point 1, 0, and cosine concerns the x value. So when theta equals, or when the angle equals 0, the result of the cosine function will equal 1. If we divide both sides by 3, we still get that 0 is equal to theta. Nothing special there. But we're going to have some extra points here because the period of this function is 2 pi over 3. It's normally 2 pi, but it's being shrunken here by a factor of 3. So the period is going to be 2 pi over 3. So we're going to have another occurrence at 2 pi, and then another occurrence at 2 pi, we have an occurrence at 2 pi over 3, and then another occurrence at 2 pi over 3 plus 2 pi over 3, or 4 pi over 3. Okay, that's 3 different results here for that one point. So let's talk about what that means now, that our polar points, our polar coordinates are theta. We have 3 of them. It's going to be when r is equal to 1, right? This is r right here. R is equal to 1 and theta is equal to 0. R is equal to 1 and theta is equal to 2 pi over 3. And then finally r is equal to 1 and theta is equal to 4 pi over 3. So I am now going to graph this function over here. Okay. So if I start out at 1 and I rotate 0 units, 0 radian is 0 degrees, I just have this singular dot. And if I start out at 1 and I rotate 2 pi over 3, so let me see if I can get a circle drawn here. If I start at 1 and I go 2 pi over 3, that leads me to this second dot. And if I start out at 1 and I go 4 pi over 3, that leads me down here. Okay, so these are the 3 points here where I'm going to have one of my max r values. So it seems so far like this rose graph is going to have at least 3 petals. But don't forget that we can have an max r value when r is equal to negative 1 as well. Okay. So we set negative 1 equal to cosine of 3 theta. Solve. Now cosine is equal to negative 1 over here. So we get that this is going to be equal to pi is equal to 3 theta. And that means pi over 3 is equal to theta. Now the period is 2 pi over 3, so we're going to get 2 more results here. So pi over 3 plus 2 pi over 3 will give me 3 pi over 3, or just pi. And then pi plus another 2 pi over 3 is going to give me 5 pi over 3. Okay? So at these particular angles, I'm going to get the maximum R values. So let us see here. So if I look at my points, R theta, then I am going to get -1 pi over 3. So let's see what that means. I go out -1 and I rotate pi over 3, so I'm going counterclockwise. But that actually leads me to this point here again. And then if I go -1 pi, so I go out here and I rotate this far, well, that leads me onto that point again. And then if I go -1 5 pi over 3, so I start here, 5 pi over 3 is actually over here. So it's kind of weird and coincidentally interesting that if R equals 1 or R equals -1 for this graph, I end up with the same 3 points. So this graph is actually going to have 3 petals, and it's going to look something like this. Okay, just like that, because you're going to end up with a bunch of little loops here, but the biggest that the loops could possibly get from the origin is a distance of 1, and they're going to occur 3 times. All right, and I've graphed it for you here, so you can see that this is actually what the graph is going to look like when R is equal to 1. Right, and theta is equal to 0. It's also the same thing as R equals -1 and theta is equal to pi. Up here is the other max R value, or where the R value occurs. This is when R is equal to